Good morning, afternoon, and good evening. Thank you for joining the Growers by Growers webinar today. My name is Matthew Grantham, and I work with Heliospectra for customers and growers across Europe, the Middle East, and Australia. Heliospectra was founded in 2006 in Sweden by plant scientists with one vision: to make crop production more intelligent and resource efficient. Today, with customers across 6 continents, Heliospectra is the global leader in innovative horticulture lighting, custom light control systems, and specialized services for greenhouses, vertical farms, and controlled plant growth environments. At Heliospectra, our mission is to redefine nature's potential through innovation, technology, and meaningful partnerships. Our commitment delivers operational excellence to our growers and their business. So thank you for joining our webinar today. We've allocated 15 minutes at the end of this webinar to discuss your questions. So please, if you have any questions, there's a question pane on the screen where you can enter them, and the webinar will be recorded, and a link to it along with the contact information for our speakers will be provided in a follow-up email. Now I would like to introduce you to my colleague Daniel, who will be moderating today's webinar. We have the pleasure of having Silke from Wageningen University, our head grower from Pure Harvest, and last but not least, the team captain Leonard from Van der Hoeven, who won the Autonomous Greenhouse International Challenge along with his teammates at Keygene, Let's Grow, and our partners Hugendorn. We hope you enjoy this webinar, and I will be back later to start the Q&A session. Thank you. Over to you, Daniel.
Thanks, Matt. I'm Daniel Bankestad, working as R&D engineer and product leader at Heliospectra. And when I'm not moderating webinars, which is rare, I'm focusing on making our lighting system better and more intelligent. Related to the Autonomous Greenhouse Challenge that forms the basis of today's webinar, me and my colleagues contributed by providing fully controllable LED lights, ensuring that the teams had a quite comprehensive light environment control in their hands. I'm very excited about this webinar because of the great panel we have here today and the different experiences and perspectives they bring to the table for a discussion around smart greenhouse cultivation practices that growers can learn from and adopt. Let's start off by having the panelists introduce themselves. Dr. Silke Hemming, Leonard Baart, and John Prince. Thanks a lot for joining today, and let's do an introduction round in that order.
Well, good morning, good afternoon, good evening to all around the world. I'm Silke Hemming. I work for Wageningen University and Research, and I'm there the head of the research team Greenhouse Technology, and we do research for greenhouse production systems all over the world on the field of climate, irrigation, and also the fancy stuff, robotics, ICT, and today I will talk more about algorithms and AI stuff. Thank you.
My name is Jan Prins. I come from a traditional growers family out of the Netherlands. Learned the job between the tomatoes starting from 12 years old and started my professional career as a tomato picker. I've been owner and operator of greenhouses in the Netherlands, but I have also built and operated companies and farms in Africa, China, and now in the Middle East. I've worked with low-tech greenhouses, medium-tech, and now with very high-tech greenhouses, being the head grower of Pure Harvest. Pure Harvest is a startup who has proven that it is possible to produce top-quality tomatoes year-round in the middle of the desert, and we're the only one so far. We are now in the process of expanding our footprint in the Gulf region with more high-tech greenhouses in which we are planning to grow different crops. Thank you, and I'm looking forward to the web seminar.
I should unmute myself. My name is Leonard Baart. I'm an R&D engineer at Van der Hoeven. Van der Hoeven is at Van der Hoeven we design and build high-tech greenhouses. I'm a mechanical engineer by background, and I've been doing quite a lot of research in greenhouses for say the last 10 years, doing a lot of simulation, modeling, and optimization. And of course, I was the team captain of the Team Automatoes. This is probably why I'm here. And Team Automatoes is a team of Van der Hoeven, Hoeven from the climate computers. So a lot of experience in the horticulture industry. And on the other side, Technical University Delft with a lot more knowledge about AI, and Keegene, who does molecular breeding. So that's me.
All right. Thanks a lot for the introductions. I want to emphasize the experience and knowledge this panel covers with expertise in modern state-of-the-art greenhouse design, control, and operation. From the academic side, that is Silke; from the greenhouse provider side, that is Leonard; as well as from the grower side, that is Jan. A few words about today's outline. The Autonomous Greenhouse Challenge is the basis for the discussion. Silke will start by giving you an overview of the competition and go deeper into key takeaways for growers, as well as making an outlook for the future. Leonard and I will then discuss strategies and goals implemented to win the challenge. And finally, Jan will come in and talk about his perspectives on innovations in greenhouse control and taking the greenhouse to the next level. And then we're reaching the Q&A session, so don't hesitate sending in your questions. Now is the time to hand over to our first speaker, Silke Hemming.
Yeah, let me share my screen. Today I would like to explain you shortly about our Autonomous Greenhouse Challenge. The challenge is on the use of artificial intelligence to remotely control greenhouse crop production, and the example is tomato production in this year's challenge. I would like to give you some analysis of the results here. We had 6 international teams, 5 teams operating with modern artificial intelligence algorithms, and 1 growers team manually operating the greenhouses. The greenhouses were at our location, Wageningen Research, in Bleiswijk, the Netherlands, and you can imagine that the reference manual team was a Dutch growers team. We had 6 equal greenhouse compartments, and of course equal staff doing still some work in the greenhouses. How was that working? Well, you see here a scheme of a greenhouse compartment having different equipment and actuators. So you have a high-tech greenhouse with roof ventilation, a double screen, 2 different types of screen material, artificial light, a mixture of high-pressure sodium and the LED lights from Heliospectrum, full control. We had hydroponic tomato growing with drip irrigation and recovering of the drain. CO2 application in the greenhouse, and 2 types of heating systems. The greenhouses were equipped with typical sensors to give information on light, temperature, humidity, and CO2. This is a picture of the real greenhouse directly after planting, and this is a picture of the typical growers, the typical sensors we had in there. Next to the climate sensors, we also were equipped with irrigation sensors, so EC, pH, and temperature in the root zone from Grodan. Usually a grower has to make all kinds of decisions. He has to adapt the climate computer, and he has to put the settings what he wants over there. He has to decide, when do I want to produce what and how much resources do I want to use for that. That is quite complicated, and therefore we would like to see if AI computer algorithms could help the grower to make these decisions. And in our challenge, we go beyond that. We try to replace the grower as much as possible. So for that, we have 5 teams all over the world. They had beforehand, they had access also to our models, which are a digital twin of the greenhouse compartments. So they could use that to train some data, but they could also use their own data. So what do the teams have to do? They have to make algorithms which automatically decide the control set points for climate and irrigation. So the output of the algorithms is these control set points. They send it to a digital interface, and they also have to make decisions on the crop treatment. How many stems per square meter, how many fruits do I want to maintain during the run. They send the information obtained by the algorithms to the digital interface. The digital interface gives the information through the process computer, and the process computer operates the actuators, so the ventilation, the heating, the CO2. On the way back, we get all the sensor data from the greenhouse, and they can be feedback into the algorithms. However, this challenge was not on replacing all the labor we have in the greenhouses, because robotics is just not so far yet. So we had people in the greenhouse who were looking at what the team were instructing on the digital interface, but then manually doing the pruning and also the wiring of the crop and the harvesting. So we had, the teams were provided by a tomato variety Axiani. Axiani is a cherry tomato crop, which is quite tasty. So they had the equal variety, but they could make decisions directly at the beginning. How many stems per square meter do I want to plant in my greenhouse? And then in the run, how many stems do I want to maintain? Do I want to increase it in the season? And here you can see the results of their decisions. They had completely different crop strategies. You can see already at the 15th of December, I think it was the 16th of December, the crops were planted, and you see teams made decisions for completely different stem densities during planting. And then you can see that most of the teams increased stem density in the season, and you see the gray team, which even doubled the stem density after around half of March. I want to point out here two colors. One of them is the gray one, and the gray color is the manual reference growers, so the Dutch growers team. They made manual and human decisions. And I would like to point out the green team, which is the team of Leonard, who is also in this webinar. And at the end, they won this competition. So focus a little bit on those two colors in order to learn something, how you can reach a very good result. The teams also had to make decisions when to top the crop. We only had a 6 months crop. Usually you would have 1 year, but due to time and resources, we cut it down to 6 months. And you can see also there, very different decisions were made by the teams. This resulted also in completely different plant loads. What you can see here is that the growers team was quite reluctant in the plant load. By the way, also the team of Leonard was quite reluctant a long time. Just at the end, they realized we have to do something. But there is the black team who had a very high plant load all over the time. The teams handled different climate strategies. And as you might know, a tomato crop is growing optimum if they receive the amount of light, temperature, CO2, humidity at an optimum range all the time. So let's have a look. So for example, the growers team, they had quite high temperatures. The team of Leonard was more reluctant until the end. I don't know what happened over there, but then they decided to make it quite uncomfortable for our workers in the greenhouse, and they raised the temperatures up to 30 degrees, I think, to boost the production at the end, but maybe he can comment himself. You can also see that they handle different light integrals. A large difference can be observed in CO2 concentration. And what we can also see is that there was a large difference in EC. There is this blue team who had a quite high EC value. Maybe we see that back in the quality of the fruits. this was the production reached. And what you can see is that there are 3 teams who reached quite high production values. That was the green team, which was first, and followed by the black and the gray team. But were they also winning the competition? Because the competition was on optimizing the net profit. And for that, you need high production and low resource use. But first, have a look at the quality. Teams could reach higher prices with better quality. And here you can see that both the growers team, but also the green team, were not at the upper end of quality, but they had large production values. Let's have a look at the resource use. What you see here is the heat and the electricity and the CO2 and the water and nutrients used per kilogram tomato produced. And you can clearly see the ranking. The green team was top. And although the growers had a very high production, but they used so much resources, you saw it in the temperature and also the other strategies, they simply used too much resources to end up high in this ranking. If you put both together, the production and the resource use multiplied by the price for the production and the costs for the resources, you get the net profit. And here you see the development of net profit in time, and you can see that the green team was quite early ahead of the other teams, but there was this orange team, the second one, who was a few times nearly catching up. Unfortunately, the gray, so the growers, and also the black team, who had high productions, used so much resources that they didn't end up high in the net profit ranking. What do we learn from that? First of all, it's quite striking if you look at that result in net profit. All 5 AI teams were able to outperform the human reference. And as you might know, the Dutch growers are quite experienced, and I can tell you our growers team really did a lot of effort to have good results. What we also saw in these results is that different climate strategies result in comparable, or may result in comparable production, but definitely in different sustainability and resource use efficiency. What we also see in the whole analysis is that the crop management is really key for high quality production, but also key for reaching a high net profit. And then I have a few comments also. If you want to apply these modern type of technologies, you need data for all aspects of the growing. So if you don't have objective data of the crop, of the climate, of the irrigation, you cannot develop those type of algorithms. And if you have data from a sensor, what does it mean to you? So how can I interpret the data? And that can be done by a human expert, but that can also be in the future maybe done with algorithms. And last but not least, I would like to point out this challenge was on making decisions, helping the growers making decisions. But until now, we still need excellent crop handling. And that can be done by excellent humans trained enough. And maybe in the future, they can be helped by more robotics in the greenhouses. I have a very last slide, if you allow me, which looks complicated, but which is a message to also all the growers, because we were interested in analyzing the data. What could our growers team have done better? So we used all our fancy models, and I don't go into detail how we exactly did that, but we took the data from the reference growers and from the winning team, the Automatoes, and we were analyzing if the growers would have applied part of the strategy of the Automatoes, would they have had a better result? And what you can see here is that the net profit would have increased if the growers would have used the lighting strategy of the Automators. They would have had a little bit lower production, but definitely a better resource use. And the second one, what we see here is if they would have applied the cropping strategy of the Automators, and therefore I point out crop management, crop management, crop management, then they would have reached a higher net profit and even a much higher production. And with that, I would like to thank you and giving some pictures of our challenge and participants, and maybe later there is some time for questions.
Thanks, Silke. Very, very interesting. And it's interesting to see the importance of both the cropping strategy and also the aspects of lighting, such as photoperiod. The natural next step is to go over to Leonard. The team that was most successful in growing the cherry tomatoes was his team, Team Automatoes. Leonard, congratulations again on winning the challenge. It was very impressive to see. It's been a couple of weeks since the final event and the announcement of the winner. What has it been like?
It's been very busy, of course. It was really nice to win. I mean, it was also a reward for a year of teamwork. We started about a year ago preparing the hackathon, and it was a really nice teamwork. So it was nice to see that it pays off, of course. And yeah, we got lots of nice reactions, publicity, people contacting us. So it's been, I was hoping it was going to be a bit more quiet, so I had time to do other stuff. But I was mistaken there. But it's a good thing.
Yeah. All right. I would like to take it a little bit one step back and start from the beginning. How come you decided to participate in the challenge?
Yeah, that's a good question, because at Van Hoeven we design and build the greenhouses, of course, and we see a very important trend. Of course, many years ago we started by only building a construction of the greenhouse, and by now we are a full service turnkey greenhouse supplier. So we design a greenhouse and we supply the whole greenhouse, all the installations, and already we help the growers in starting up. So we do a bit of training and we prepare them, and sometimes we bring in a grower like Godfrey Doll is one of my teammates, which is currently starting up a greenhouse in Kazakhstan. But what we see is that we're having more and more investors as clients, and they want more full service. So they don't only want a greenhouse, but they want a greenhouse with the crop in it and a well-performing crop. So that's the trend that we see, and this fits perfectly in that trend. So that's why we participate, and of course we cannot do that all alone. So that's why we need the partners that I mentioned already before.
Yeah, it sounds like a well-composed team with Van der Hoeven, Kijin, Hugendorn, and Let's Grow. Yeah.
Yeah.
And also the growers' input, as you mentioned. How did you approach the problem formulation? How did you approach and develop a strategy?
Yeah, the thing we started out with, and I think there it's not a whole lot different than the growers, is that we started out by putting the plant central. So we really try to optimize around the plant. The whole greenhouse is around the plant. So we believe that you can only do well if you let the plant perform optimally. So you design the whole system around the greenhouse, and if you do that, you don't only have a good production, but you also are efficient, and that's also something that Silke, of course, has really noted. So, and we sort of follow the plant empowerment strategy. I'm sure you heard about this. It's all about keeping a plant in balance, and you have this short-term balance, which is like in 5 minutes, and you have this long-term balance, which is something that you do with the crop, and you only notice it after a week or maybe 2 weeks. So we made something for both those long-term and short-term loops, and we automated around that. So we did not try to mimic a grower. because we believe that if you take a lot of data from other greenhouses and you train a model on that, you sort of get what they are doing, but it's not optimal. So we thought that's not going to work. We really tried on using the data from this greenhouse only. Of course, we do need a lot of background because we have to know what are the limits for a crop, for example. So there, yes, we rely on historic data. But our strategy was to use as much data from this greenhouse only, and perform on that. So, and then we broke it up into pieces. So we didn't make one model, but we were really looking at what is the grower actually trying to achieve. So we had some really nice discussions with our grower, and what are you trying to achieve? And as I said, plant physiology at the same time. And then the biggest problem is actually to objectify and quantify. So what is he trying to achieve? And then it's not a bit of this and a bit of that, but really need to bring it back to a number. And if you bring it back to a number, then you can do something with that. So we broke it down into pieces, and then we chose for each of those blocks, we chose AI. So not AI, one thing to do it all, but just really, AI is a toolbox, of course. It's not a goal in itself. So if you bring the problem down, a smaller problem, you find a piece of AI to fix that. And yeah, I think that that worked out really well, actually.
Yeah, that's very interesting. Can you give some more concrete examples of strategies that you carried out in the greenhouse?
Yeah, one really simple example is that we did with the irrigation. So we looked at the sensors in the slabs, and we had a lot of discussion with the grower. What are you trying to achieve? So he's trying to achieve a certain dry down, which means the water level at the afternoon when you stop, and when you start again in the morning. You want to achieve a certain level in dry down, and then with that way you can steer the crop a bit in the long-term balance. So what is really important is the time that you stop in the afternoon, because it will determine at what level you reach in the morning when you start. So once we identified that problem, and then we made a model which it's actually a fairly simple regression model which predicts the dry down depending on the predicted conditions in the outside and in the greenhouse. And with that model, we could then fairly simply calculate the right stopping time. So that's actually a very, very simple example. Of course, a bit more complicated example is the ventilation, because I think the ventilation is probably the most important part to control a greenhouse. It's also the most tricky part, and we didn't want to use the normal way of doing that. So the normal way of doing that is a P-band control, which means that from a certain temperature the windows start opening, and if it's a bit hotter then it opens more. And we think that it actually means that you're ventilating too much, that they are ventilating too much in the conventional way of controlling things. And this is really important, as I said, in achieving optimal growth, but also in the resources efficiency, because you need to have balance. So that means that if radiation is high, you also at the same time you want a high CO2 level, you want a high temperature, because then you will have maximum photosynthesis. But you also need to watch out that you don't have too low humidity, because then the stomata might close, and that's what you don't want. So we made a model that predicts the behavior of the stomata, and then we can from that we calculated the window control, the window opening, and then we keep looking at the stomata, and you cannot look at them directly. So we have to calculate sort of what they will do, to predict what they will do. Yeah, so that's actually another example of what we did, and that's for the short-term balance. And then of course you have the long-term balance, because we have the temperature now, but we also have the temperature in 24 hours. And that's also really important. So you have to look forward, because that 24-hour temperature gives you a way of also steering a plant, because on a daily time scale, the radiation has to be in balance with the 24-hour temperature. And that's actually what we used in the feedback loop. So we made, based on the weather prediction, a climate plan to steer the 24-hour temperature to what we want. and then adjust that. That's based on the ratio between temperature and light. And then we looked at the plant, what's happening, because the plant is telling you, is it still in balance? And if it's a bit off balance, we adjusted that ratio between temperature and light. So that's that's another example of breaking it down into a block and then finding how to solve that.
Yeah, thanks. It's great stuff. We could talk about this for a long time, but the time is going. One quick final question. What is the next step for you and your company? I assume you will continue along this path, but how? What is the short-term and long-term plan and vision?
Yeah, the long-term ambition obviously is the greenhouse without people, but that's also what Silke said. It's a long time away, because we need automate for the crop handling, and that will be many years. But what we will see is, so on the long term, we will do research to reach that. We will do research, which is quite long term, and we tried this new control based on only data instead of models. So we will do a lot of research. On the midterm, we will start taking over greenhouses, actually, the climate control. And it's not too far away. I expect that to be within a few years well possible. And on the short term, we are taking steps. So obviously, I want to take it to a semi-closed greenhouse, because in the challenge we had a conventional greenhouse, and in a semi-closed greenhouse, I think control can be better, so we can have even better results. We will do more tests. So we already started some tests with a similar approach in tomatoes, but also in lettuce. And we will use some of these techniques just to monitor greenhouses, some of our greenhouses that are currently somewhere around the world, and we can see if we can help them with some advice to perform already better. So, and then some pieces of our approach will, I think, and especially for Hoeven, because they will put it in their climate computers, they will add some of the modules that we use, develop it a bit further into a commercial product, and then start selling that also quite soon, actually, within a year, for example.
All right. Thanks, Leonard. All right, and by that, I want to switch over to John Prince, head grower at Pure Harvest Smart Farms. Can you share a little bit of your perspective on what we have heard here today and where the industry is going, and share Pure Harvest's approach to smart greenhouse cultivation?
Yeah, thank you, Daniel. First of all, very interesting what Silke and Leonard has told us. I want to share my perspective on how I see the greenhouse developing in the future. If we look at the history, then we can say that for years now we have worked with different sensors related to climate, irrigation, and other sensors that always have helped the grower in making the right climate and irrigation decisions in a greenhouse. Now, recently, we have seen a move to more plant sensors that assisted the grower in understanding the plant behavior. Coming from reading the plant only by observations, the plant sensors are more and more becoming tools that the growers uses every day. And in Pure Harvest, we want to bring this IoT-enabled horticulture to another level. Not only we are collecting more data about our water flows, energy consumers, and CO2 flows, but recently we also have installed photosynthesis sensors to collect more insights about one of the most important processes on this planet. The next steps we're planning to take is combining and analyzing all this info in tailor-made dashboards that in combination with artificial intelligence can assist the grower. This, of course, for a lot of growers is nothing new, but under desert conditions and with the amount of data that we have, I can say it is unheard of. In our small farm in the desert, we easily count more than 50 sensors that are all collecting data, and this with different types of tomatoes create a massive amount of data, which without artificial intelligence and or without dashboards will take the grower too much time to analyze. It is also maybe good to mention that at the moment we're doing a trial with heliospectral LED lamps, which sounds a bit strange to most people, but we like to investigate even in the UAE if additional light can add value to our tomatoes during the winter season or during interplanting. Our our strategy is to move to more data-driven growing, which is important for us because we believe it can help us being more sustainable, more profitable, and can help us with our ambitious growing plans. You can see that, for example, in our hiring plan, whereby IT specialists, data analysts are recruited next to the more traditional grower. We believe that our team of people will make green fingers digital. This more traditional grower will also move to more and more data-driven decisions, like we have heard from the previous speakers. And in that regards, the role of a grower is changing. He should try to make a connection between what the plant tells him and the analyzed result that the dashboard, for example, provides him. Like everybody, I also expect that more data supported by analyzers will more and more help the greenhouse grower to achieve better results. And although greenhouses are necessary to feed the world for reasons like higher productivity, food safety, more sustainable, we should not forget that it is not always as high-tech as in pure harvest. The average farmer in developing countries can easily triple his output with a simple plastic greenhouse and a drip line, but even here data can help. Weather forecast or market information on his mobile phone can help the grower in supporting his family. More centralized platforms that provide, for example, market info can also do the same. In short, I'm enthusiastic about the time we're living in. The horticulture is accelerating in IoT-enabled growing and is becoming more and more interesting. It becomes more and more interesting to be a grower. We only should not forget that growing is not only about climate and irrigation, like Silke has told us also. There are also disciplines like crop protection, cultural practices, work schedule, planting programs, variety selections, and much more. So if somebody thought here that you can buy a greenhouse, put the power plug in the socket and go to the beach, then I'm sorry to disappoint you, since that is still a long way away from us. For now, the greenhouse needs a grower like a plane needs a pilot. And although the plane can fly automatic, the pilot is still there for good reasons. And I expect that the grower, for similar reasons, will stay a crucial factor in growing healthy fruit and vegetables. So far, my perspective on the grower in the future, and looking forward to the discussion.
Thanks, Jan. I have a question for you directly, if that's okay.
That's okay.
You're growing in the desert, and I think it poses some challenges in terms of the temperature and things like that. How are you handling, and what is your strategy around ventilation and cooling and resource use efficiency? Can you elaborate a little bit on that?
Yeah, I think I'm a very fortunate grower. There are only a few growers in the world who have so much sunlight as we have here. So that is a fortunate thing. And more than that, we have seen that we can transfer all the sunlight into healthy tomatoes. And other than that, as a response on your question, keep your greenhouse closed.
All right. Leonard, do you have anything to add to that? Do you agree? Now you're muted.
Oh, and then someone unmuted me. No, I said, what can I add? I fully agree. Keep your greenhouse closed. Well, of course, in different regions of the world, things can be quite different. But in this case, it's pretty obvious, I think. Yeah.
I think one thing we have learned here in the desert, Daniel, is that I think it's similar what Leonard said. If you have enough light and you have enough humidity, the temperature that a tomato feels comfortable with can be much higher than we ever thought of. So it is a combination of factors which open new doors, I would say. We are very much in line with the new growing, as we call it in Holland. But I want to call this new growing 3.0, if you allow me.
Thanks. And then I also I have I have a question for anyone in the panel related to sensors, because that is an important component for automatic control. That they need to be reliable and objective and functioning and providing useful information. From your perspective, what sensors are important, and what are the trends and also the needs going forward?
I think that of course, the most important sensors are still the traditional sensors, right? So temperature, humidity, CO2, they are standard in every greenhouse. But we said that we need at least to do what we want to do, optimize control. We need at least to look at the roots of the plant. So we need some information about the water uptake. So that can be through the slab sensors that we used, or you can use a scale alternatively. So we have to look at the roots of the plants, and we have to look at the top of the plants. And as I said, we want the stomata to be opened. And for that, we really need the plant temperature. So that's also pretty straightforward that you need the sensor there. In my opinion, those are the two most important that is currently not standard that we need. I don't know if Silke agrees. She's Silke.
Yeah, no, well, as you remember, I asked this question to all the teams. What do you think is was the most useful sensor? And I got a different answer from all the teams. There was even a debate, is it the traditional sensors which you have, which are cheap and gives you information on climate and root zone, or shouldn't we gather direct more information on the crop? I think Jan just gave a good example, measuring photosynthesis directly. I would like to give a completely other example to see it from a different perspective. What growers currently are doing is they gather simple data on the crop status manually. They count the number of flowers, the number of fruits, and in order to get information. I can tell you, we have a lot of experience in that. On Monday morning, a grower is counting different than on Friday afternoon, and grower number 1 is counting different than grower number 2. Even though you think it's the same information, it's not. And I think one important step towards the future is to get this kind of information objective, and that you can really use it also for algorithms, because you want to have it the same all the time. Like you have light is light.
I completely agree. I was just talking about the sensors that we have now, but I fully agree that we also involved in some sensor development that, of course, looking forward, that we can do a lot more, and I agree with Silke.
But of course, the next logical step is also that the grower digitizes this data, not writes it down on paper, but uses an app to digitize the data, which is a more simple step people can take.
I think if there is a technology at the moment available that counts our tomatoes on the plant, then every grower will immediately shift to that. But in the absence of that, we still have to count on Monday morning. But more and more sensors, I think what we have seen worldwide, that growers are embracing the sensors that come on the market. And there is a little bit a forest of sensors at the moment from different suppliers. So yeah, we have to be smart in choosing what is useful, what is reliable. And I think from a grower's perspective, we are very much enthusiastic about all the tools that we get available at the moment.
I would like to comment on this reliability. It's very important for all the growers out there. It's very important to choose sensors which are robust and easy to maintain. And there are many new fancy sensors where it's not clear what kind of information you get out there or how to use it. I think we will get a time where you get all kind of data in the greenhouse, and then we know which ones are useful, and then we get much less information in the greenhouse again. That would be my prediction.
I agree, but what you can also if you do some good systems engineering, you can combine sensors, and not in the way that it becomes dependent. But if some sensor fails, which happens a lot, of course, there should always be fallback scenarios that you use another sensor. So never trust one sensor only. That's it's important thing to do.
And you can also combine sensor information from different types of sensor, which tells you more than the single sensor.
Yeah, all right, good. So we are a little bit in an exploration phase, investigating sensor fusion and what information can be extracted from different types of sensors that are useful for the growers. If I'm not wrong, I think it's time to jump over to the Q&A session of this webinar. Matt, are you with me?
Yes. Thank you, everyone. That was really, really good. So I'll jump straight into the questions because we haven't got much time left. We've got about 15 minutes. Where are we? So this one's to Leonard. Congrats on your win. I'm not sure who that's from, but we'll get that information later. But they want to know the frequency of the fertigation, the timing and the amount. What time did you stop? And what was your target? Air CO2 or the oxygen levels in the substrate?
That's a lot of questions. What is important to know is that we had to, so we could send instructions for the irrigation, so the interval time through the API, so we could automate that every 5 minutes. So we send new set points every 5 minutes, and considering the irrigation mix, we could there decide once a week only. So we could not change that all the time. And we had to work with, as I said, the slab sensors. And the slab sensors gave us information on the temperature of the slab, the EC in the slab. And how am I missing? I'm missing. Silke, can you help me out? Sorry?
pH.
pH, yeah, pH. And then we had also some measurements of the drain. So that's what we were working with. And besides that, we got some lab results, but we got them once in 2 weeks, if I'm correct. So there we got the analysis of the mix that was given compared to the mix that was measured from the drain. So there we could see what the plants were taking up, and we did not have direct information on the oxygen level in the roots. So we were controlling that indirectly. Did I answer the questions?
I think so, but we're going to follow these up, yes, with the question, people who ask the questions later. So this one is for Jan, or for anyone really. What has been done using AI for pest and disease management? I mean, we've seen a little bit from a lighting point of view, but is there any sensors on the market that this is open to anyone, really?
Yeah, I like to say something about it without making too many advertisements. But Koppert, a well-known company, I think, out of Holland, has recently introduced an app whereby scouting cards can be read through the app. We are implementing this at the moment on our side, and I can say it's quite useful. That is actually the app is not only there for reading the scouting card, the sticky card where we normally count the pests to observe if they increase or decrease, but the app can also manually take information throughout the greenhouse. And I think this technology will evolve in the coming years, whereby more and more will go automatically by cameras, by smart cameras. But that is what I can say about it.
Thank you, Jan. Anyone else? Daniel, maybe you have some points as well.
Not really, but I mean, it's interesting because it's a real problem with pests and diseases in greenhouses, and sensor developments in innovations related to early detection of such things can have a big impact in the future, I think.
Absolutely.
Maybe add from the research side, a lot of work is going on here to directly detect pest diseases or biological control agents inside the greenhouse. However, you have to be aware there are so many and they are so small, and they are sometimes living underneath the leaves. So direct detection is a challenge. But a lot of work is going on there. You could also think about indirect measurements in DNA analysis, odor analysis. So there is a lot of work going on, and we might expect much more in the future.
And also there is a lot of work going on related to lighting, related to plant resilience. For example, implementing lighting strategies to induce more resilience, or making the plant more more resilient in that way. Yeah.
Great. Oh, we'll move away from pests, and this is talking to Jan, being in the desert, but it touched on what Silke mentioned about crop management and efficiency. How do you do anything to improve the efficiency of heating and cooling of your greenhouse? Obviously, lighting and heating is a big energy user in the greenhouse.
Yeah, now at the moment we use only sunlight. I told in my presentation that we're doing a trial with heliospectral lamps, but that is just a trial at the moment, which looks promising, I would say. So our light source is sunlight, which is free and in abundant amounts available here in the desert. And maybe it's good to say that this whole thing might change the way we think about farming. We used to farm in places where we have a good climate, a good soil, and good water. But it might turn out in the future that we have to grow in places where there is much more sunlight. For example, the desert. Now, I don't want to walk ahead of strategies here, but it could be something to think about. If you talk about energy efficient, of course, that's a big issue in our company, and that's also the reason that we put a lot of sensors to measure our water flows. We have smart sensors which register the electricity all our electricity consumers use, and we are working on putting that together in a dashboard so that at the moment, at some point, it will not only be creating the right temperature of humidity for the tomatoes, but in the most energy efficient way, in the most sustainable way. And that is also the reason behind the data collection and the dashboards that we're trying to build in, which will be supported by algorithms, like Silke mentioned, because the amount of data, like I said, becomes bigger and bigger. And but we need to have that analyzed by artificial intelligence, otherwise it becomes not manageable anymore. But like I said, energy is a big issue for us. So we're focusing on that in terms of data collection and analysis.
You're muted, Matt.
Thank you. So this is the autonomous tomato challenge, looking at were there any unusual conditions connected to sunlight or temperature during the test? Or was everything as expected?
No, not always everything goes as expected. I think one of the unusual things I just show that Leonard raised the temperature in the greenhouse up to 30 degrees, even above, because I showed averages at the end in order to boost production. Why he did that, I don't know, but it happened. Maybe also what we did observe in the last challenge, because there we had even more unusual conditions. We had cucumber production in the first challenge, and there was a team really going to the limits of artificial light, boosting the temperature really to the upper limits. And what you saw over there is that it was working quite well for a short period of time, but then the plant gets exhausted if you go beyond the limits. And so you also have to be careful in that. Find the plant balance. That was the magic word.
Leonard, do you want to say something about those high temperatures?
Yeah. It was a question also that was asked. Obviously, we had a presentation for the jury, who decided on the final win, and also had to decide on our approach. And they asked us, of course, the same questions, because it's really quite strange. And what actually happened is that we had this fully automized temperature control, as I just described. And that was working really well. I think you can, and that's why I also want the data so much. Everyone can see that it was working really well. But Silke also showed that the topping dates differed. So we thought that we might have topped a bit late. And what we know is that if you raise the temperature, that speeds up the ripening of the tomatoes. So we had so many tomatoes left on the plant, and then another calculation says that you can reach this temperature, and we will end just in time. So actually, we took the control that we've been using for many months, we took it off, and that went wrong. I think we were pushing the limit, and we just went over. And there we also learned that the limits are really subject also to the specific variety, to specific location, and that's so that was also an important lesson to us. But you do have to realize that this was a competition, and that probably a grower would never, in a normal crop cycle, would never push it this much and would not take that risk. So yeah, that's a bit of background on what happened, and we found the edge. Let's put it that way.
You're
maybe I have another example, if I have time to add. And this other example comes from the growers. As you might remember, the growers doubled the stem density at some moment in time. And actually, Dutch growers would do that, so that's not completely unusual. However, was it wise? Well, you can see that they had a good production with that, but they lost on net profit because this is a very labor-intensive exercise. And I think there they couldn't, or maybe they didn't take into consideration that it would have so much added to the costs. I got many questions from Dutch advisors on that. So why was it negative what the Dutch growers did? Yeah, that's the reason, labor cost.
Yeah. Makes sense.
Thank you both. And looking at, you mentioned, Leonard, speeding up ripening, and obviously in the challenge, profit was the main goal, with the least amount of resources used. And Jan, maybe you have some comments on this as well, but do you have any tricks to increase the fruit weight rather than the vegetative growth of the plants?
That's a hard question for me to answer, because I'm not the expert in that field. Probably Jan knows a lot more about that. What we're trying to do is make optimal use of daylight. So already in the beginning, we made a lot of calculations on how many light is available, and adapted our whole crop strategy was based on using fully the daylight. So that's also where the stem densities and the crop handling instructions came from, and continuously monitoring the light interception of the crop, which obviously influences. There's also fruit pruning, of course, which I think has a lot of influence on the fruit weight, but maybe Jan is better to comment on that if they want really practical tips.
Yeah. No, it is always difficult to talk about the crop which you don't know the history for or the location. But what you can say about a plant that is not in balance, because if there are too many leaves and the fruit size is not big enough, you can say the plant has the balance is not right, too much vegetation. One very practical way is taking one of the 3 leaves out of the head. So between 2 clusters, you have 3 leaves. You can take out 1 leaf in the head of the plant to re-establish more balance between vegetation and fruit size. Other ways to influence this is, of course, water management, climate management. You can think about big differences between day and night. Could be one of the reasons. But this is dangerous to say from me, because I don't know the crop, I don't know the location, I don't know the conditions. But maybe the most practical tip is taking one of the 3 leaves out at the head of the plant every week, 1 leaf, and you leave 2 leaves between 2 clusters. That could be a practical tip.
Can I ask a question there, because this was also a discussion during the challenge, and we did not do that, and we know that it's quite common practice, but we think it's not really based on there's not enough objective information on that, and no data to support that. But maybe Silke can do you know if there is?
Well, I'm also not a plant physiologist, yeah, but there is information on that. So actually what you need to do is to balance the amount of sugars made by the leaf area and the amount of sugars transported to the fruits. If you not have enough leaves, it's not you don't have enough sugars to be made. If you don't have enough fruits, it cannot go somewhere. So this needs to be in balance. That's the reason behind it. So you can play with leaf area index, like Jan indicated, taking out young leaves, because that's the most efficient way. The other one is pruning or leaving more tomatoes on the vine, which also helps in there. And I think Jan mentioned the climate and irrigation strategies already. So there is quantitative information on that.
Yeah, but not so much about this taking the leaves out of the head, I think, because it's a really common practice, but there's no data supporting how effective that is.
Yeah, there is a research on that, and for example, if you use crop models, then you could also do that calculations.
For Leonard, for some decisions, a grower don't need any data. We can see if it's good or not.
I know, but we want to objectify things, and then we can use it in control. And obviously, there will be quite for a while a grower inside the greenhouse, but I'm sure he has enough work to do, and he will have enough to do in the future. So we can help him with everything that can be automated. But then we have to objectify things.
I agree.
The problem is also every tomato variety will show some different reactions here, right? To find that right balance.
All right, everyone, we could go on about that for a while, it seems. But yeah, thank you everyone for your time, and hello again to those of us you that joined late. My name is Matthew Grantham, and I would like to thank you on behalf of Heliospectra for attending this webinar. I also wanted to thank again our speakers Daniel, Silke, Leonard, and Jan for their valuable insights. Also, we have a webinar coming up this Thursday for one of our clients, Ljusgårda in Sweden, talking to us about their ultimate vertical growth from 0 to 7,000 square meters in 3 years. And a link to register for the webinar, along with the recording of this webinar, will be provided in a follow-up email. So again, thank you for joining us, and have a great day.